Hello students, welcome to Himani Coaching Center. Today we are going to do two important numericals from current and electricity for class 10th CBSE and ICSE board. So if we look at the first question, let us look at this one. We are asked to calculate the reading of A, which is an ammeter, when K is closed, and second when K is open. So I hope you guys know that K is a key. So when it is closed, what does that mean? That means this 4 ohm resistor will be connected in the circuit. And when it is not closed, which is what is given in the diagram, then the 4 ohm resistor is not connected in the circuit. Also, you would have noticed that 4 ohm and 8 ohm resistors, they are connected in parallel. How do we know that? So the easy way is you look at this is plus here. So this means this end of the resistor is plus and this end is plus. Automatically the other end becomes negative. Now if plus and plus of two resistors or three resistors are connected, that's a parallel combination of resistors. So let us now look at the first part when K is closed. So when K is closed, and I will again show it like this. So 4 ohm and 8 ohm resistor, they are connected in parallel. And how do we find if two resistors are connected in parallel? The effective resistance Rp is equal to R1 times R2 by R1 plus R2. So let's do that and find Rp in this case. So it should be 4 times 8 by 4 plus 8, which is giving us 32 by 12 or 8 by 3 ohm. So when the K is closed, the total resistance of the circuit is 8 by 3 ohms. The potential difference of the battery or EMF of the battery is given to us as 10 volt. We will apply Ohm's law, which is V equals IR, and we have to find reading of ammeter. What does an ammeter do? It measures the current flowing through the circuit. So that means we have to find I. So I is equal to V by R, and hence it is 10 divided by R, which is 8 by 3, or we can just write 10 times 3 by 8, and the answer is 15 by 4 ampere. So that is our answer for part 1. Now, let us look at question number 2 of this. It says when the key is open. So if the key is open, that means now 4 ohm resistor is not connected in the circuit. The total resistance of the circuit now is just 8 ohm. So when K is open, we will say R equals just 8 ohm, V is 10 volt, and I is just equal to V by R, which is 5 by 4 ampere. Okay, I hope this is clear to you. In case you still have doubt, you can rewind the video and watch it again. And in case you have not subscribed to the channel, do subscribe it, like it, and share with your friends. Press the bell icon because we are going to come out with many videos for maths, physics, and chemistry to help you with board questions which you can expect or which have been which have been there in the previous boards. So you will get lot of clarity before your board exams. Now let us look at question number 6, which is for me question number 2 here. So it says in the diagram given below, ABC are three ammeters, each of negligible resistance. The ammeter B reads 0.5 ampere. Calculate the reading of ammeters A and C. B is the total resistance of the circuit, and C, the EMF of the cell. EMF means electromotive force. Now, let us understand about current. See, current flows from positive terminal of the battery to the negative. So this is current I. So it is flowing through ammeter A, and 6 ohm and 3 ohm, these are in parallel. As I explained in the earlier question, both of these positives are connected together, and this is negative, negative. This 2 ohm, this is negative, so other will become positive, okay, because it is connected from negative here, so negative and positive. So this combination of 6 ohm and 3 ohm is in parallel. So current I gets divided into I1 and I2. So I1 is already given to us because it says that current through B is 0.5 ampere. Okay, that's the ammeter reading. Now let us understand one of the characteristic of parallel combination of resistors. In a parallel combination of resistors, the potential difference across the resistors remain the same. So let us say this is R1 and R2 and they are connected in parallel. Yeah, this is parallel combination. So the potential difference across them would be same. So that is the property of a parallel combination of resistor. In case of a series combination, the current flowing through each resistor is same. Now coming back to our question, we can understand that if I have to find A, I should know what is I. If I have to find C, I should know what is I2. Now, going back to the property of parallel combination of resistors, let us understand from the given question, what is the potential drop across 6 ohm resistor? See, the value of R is 6 ohm. The current flowing through this is 0.5 ampere. So, potential drop across 6 ohm resistor is equal to V equals IR, again Ohm's law. So that should be equal to 6 times 0.5 ampere. So it is 3 volt. Now having figured out this, we will simply say that potential drop across 3 ohm resistor is also equal to 3 volts. Okay, I want to find potential drop. I figured out that that is 3 volt. So what would be the current, which is I2 here, through 3 ohm resistor? So I is equal to V by R. So 3 by 3, which is 1 ampere. So current flowing through 3 ohm is 1 ampere. So reading of ammeter C should be 1 ampere. And we know that I equals I1 plus I2, and which is current flowing through ammeter A. So we will simply say it would be 1 plus 0.5 or 1.5 ampere. Now, let us look at the other part of the question where we are supposed to find the total resistance of the circuit. So again, first thing what we need to do is find the effective resistance of 6 and 3 ohm. So we will simply write 6 ohm and 3 ohm are connected in parallel. So the effective resistance for both of them again should be equal to what? R1 R2 by R1 plus R2. Let's do that. 6 times 3 by 6 plus 3, which will give us 18 by 9 and 2 ohms. Now let us redraw the circuit. So we have a 2 ohm resistor here. We have a 2 ohm resistor here for the parallel combination. I'm not keeping the ammeters. Just understand this is plus minus. So this end is plus, this is minus. This end of resistor is minus, this is plus. You can see plus of one is connected to minus of other. That's a series combination. So now what is the total resistance of the circuit? It should be 2 plus 2 or 4 ohms. So that is how we figure out the total resistance of this circuit. Now, coming to the last part, which is we have to find the EMF of the cell. Now, what does the cell do? Cell is providing the electromotive force, okay, and that electromotive force is responsible for moving the electrons through 6 ohm, 3 ohm, and 2 ohm. We have already figured out the total resistance of the circuit is 4 ohm. We have already figured out I is 1.5 ampere. So what should be the EMF of the cell? So EMF V equals IR, okay, is equal to 4 times 1.5, and that is 6 volts. So this is how we approach numericals related to electricity and current. Again, do like, subscribe, and share the videos with your friends. Keep the Do press the bell icon because we are going to come out with lots and lots of videos to help you with your board preparation for physics, maths, and chemistry. Thank you.